Hey guys, again and welcome back. I am very sorry that the last video on building this thing went so long, but I want to talk to you about how much I paid for all of this stuff, and I also want to take it apart and add some three conductor wire so I can actually do testing on it. So I'm going to unscrew the faceplate, which I'll speed up, and then I'll get back to you after that. Okay, now that we've got that stuff off, I want to start with this plate here. So this is a double receptacle plate, half block off, half, I think this is called Decora style. And in white, just because it was the cheapest price, this was about $5.20 on Amazon. It would have cost me about $7 at the local hardware store, so I got it on Amazon, 2-day shipping. This GFCI plug here, which also needs to come out, was actually kind of expensive. So these are $15 from Amazon, but it's definitely a made in China component. And there is a certification on it in case you're worried about me. I'm fine. Don't worry about it. But it is ETL and CETL. So ETL, I think, is Intertech or something. I think they're legal for use in Canada, but typically in Canada you want the CSA rating, not the ETL rating. So a little bit sketch-tastic there, but that's fine. I also want to make sure this is well and tight. The ground is what could literally save your life, so you want to make sure that is tight. Okay, so the box here was just about $6 as well. This guy, oh yeah, sorry. This guy was $15 from Amazon, but they're about $25 from the hardware store. This box actually did come from the hardware store, so that's good. I have run this a little bit, and I can see these connections did not get hot, which is fantastic. That's always good to know. This unit here with the fuse and the switch and the IEC connector, this was $13 off Amazon. You cannot buy these locally. I'd have to buy them from a sort of like an electronics parts store type thing, and that would have cost half of a fortune, maybe a full fortune. I don't know. I think that's about it. Oh yeah, this pedal. This pedal was $13, and the Amazon listing said it had 18 centimeters worth of cord, but I can tell here it has about 4 feet worth of three conductor cable. It really doesn't need three conductor unless you want to use both the normally open and normally closed contacts as well as the common. As it is right now, this actually works phenomenally, but now I think it's time to wire up a flying lead because I need to be able to test some devices with it. So I'm going to split this a little bit higher up on the flex here. Being careful not to cut through the insulation of the individual wires. And by the way, if you're not in a hurry, you can get these parts a lot cheaper off eBay. But, you know, it was a little bit risky. Make sure I didn't cut any of these. A little bit chewed up, but not too bad. It was a little bit risky to buy off of eBay for things like this, because this guy, I really want it to be certified. So I would rather go someplace in Canada, so then if something goes wrong, I have recourse. But I mean, these electrical boxes are cheap. In fact, I could have got a $2 one made of all metal, but you know, I went with this. This is nice. It's got the nice cable clamps on the inside, so that's pretty good. It's not made really for these flex cables. It's more so made for like house wiring to come in. The only thing I don't like is that they don't really care if this sticks out because this is inside the wall, but for me, I'm going to use it on the bench, and I'm going to have to screw this screw in quite a bit further in because I need to use another ground. I could share the ground with here. That's an option, but we'll see when we get there. So now I need to cut a respectable length of this. It has to be long enough to give me enough slack, but not too long that it gets in the way. So I'm guessing about here should be right. Snip that down. So now I got a length of flex. This is about 1.5 feet, about 18 inches. Let me actually give you, I could give you a real inch measurement here. This is, let's see, this side. So from end to end, it is 20 inches. So there we go. And that 20 inches is in centimeters, roughly 53.5 or ish. Something like that. All right, I'm going to pass it through this box first. And this is going to be mounted this way. So I want to bring it in probably here. So this works perfectly because my switch will be over this side. My IEC cable comes in this way. And I should be able to have my load coming out that way if I don't want to just plug into the GFCI socket, because I could also do that. So let's see. I'm going to go over here, poke that in there. Okay, pull some length through here. Need enough working length. And then I can cut this open about here. Hopefully that'll be enough cable that I can work with. Okay, here we go. All right. So now, don't worry about these confusing cables. It just is what it is. So they say your load is on this side, and your load means anything downstream. So you can connect like 3 outlets sort of in series with this one. It's sort of in series, but I guess it's more in parallel. But this side here is all protected by the GFCI. Okay, I can also put the wires straight in here. Maybe I'll put the wires straight in there. So we're going to run as if black is hot. Same thing as if it were like house wiring. And the only thing is we're going to run the red to be the live. I mean the ground. What am I saying? So live is black. Neutral or return. Oh, wow, this cable is tiny. Not powering anything high current, that's for sure. Okay, so we're going to put our live in here. And I suppose ideally I would have something with a matching color. This is not ideal. This is not for anybody else's use but my own. Okay, so that's well clamped in there. Do the same thing for the white here. Need a good length. Sort of like that. I love when these things give you a guide as to how much to strip. The Wago connectors, or the fake Wagos, do the same thing. They give you a guide on the back. Okay, this can be stuffed into this side, like so. That crimped that very tightly. And now my ground here, this is my only issue. I really like my ground to be on a nice secure location. The only place for it is in the bottom of the box. So I may end up putting it in the bottom of the box. I can pull some cable out now. It's not needed to have all this cable through. I'm just pushing on that clamp and putting pushing on the clamp and pulling. Yeah, it's not going to be easy to get this ground wire attached somewhere, and I really do want it attached. So I think the best place is going to be to put it in the bottom here, clamped tightly onto that screw. As always though, I didn't give myself enough length. Gonna form a little hook like that, shove this whole thing down this way. I'll have to be able to somehow get this thing all the way at the bottom there. Yeah, it may not be the easiest thing. To be honest, with most of the things I'm going to do, the ground is not going to be connected. So it's not like I'm losing out on too much for not having it there, but it's important for my sort of mental well-being that it's there. Let's see if I can slice up on the side where the red is here. Oh, trying not to slice my fingers. I'm not sure if any of this is in shot, by the way. I always seem to take the hard way around to do things. I know my shop foreman, who I've learned pretty much all of my trade skills when I was an early entrant to the trade, he used to give me crap about taking the hard way around when he knew easier ways to do things. But how it worked in my brain, and how it might be still working right now, is that I want to see how hard the hard way is. And honestly, by taking a few, I would say, long cuts the first time around, first time trying stuff, I have found some useful shortcuts as well. So that's my excuse, and I'm sticking to it. Okay, again, this ground wire is going to be connected. There we go. That is well and truly connected. And now we can reassemble. Shove everything in the way. There we go, or out of the way I should say. Alright, just need to screw this back together. I'll speed that up and bring you back. Okay, well, now that the tedium is gone, this would be now dangerous to plug into the wall, so we need to go get some connectors to put here, but it has to be something that insulates these from the outside world, because these guys, whenever this foot pedal is pressed, mind you, when this is plugged into the wall, will become live. So let me get some connectors to do that. So the connectors I have chosen for the task are these Wago style connectors. And the reason for that is they are quick connect, so I can lift this lever and put this wire in. But once this wire is in, there's no easy way to get to these contacts. I mean, even a regular sized screwdriver will have issues going and touching the little terminal on the inside. I can also clamp something in there, like I can put a piece of empty heat shrink or empty, like the outside of a silicone wire, just a silicone part, and it'll be even more secure. So it's very difficult for you to access the inside here under normal use. Little leads like LED leads and stuff will slip in there, but usually it's not going to be a problem. At least it's much less of a problem compared to some of the other solutions there, like other spring terminals. So I think this here is a valid option. So I'm just going to strip back these 3 wires here, and over here it shows you need to strip 10 mils off of it, and they give you a guide. See, 10 millimeters right there. So I'm going to pop that here and strip. There we go. Open up one of these connections and pop that wire in, slam it down. That wire's going nowhere. So this one's fully insulated. This is the ground, mind you, but it's fully insulated. Fully enough, at least. Go for the next one. Need about 10 mils, which will be here. These connectors are great. They work on solid. They work on stranded. I don't know if they work on aluminum wire. That'd be interesting. Like the non-tinned stuff, I mean. There we go. That's not going anywhere. And last one here. Grab 10 mils off the end of it. Sort of like there. This is super thin wire too. I wasn't expecting it to be that thin, because it says 18 gauge on the sheathing, but I guarantee you this is not 18 gauge. Okay, open that up like so, and snap that down. Got a strong connection, and now these guys should not go boom when we activate. And even if it does go boom, I mean, look, it's as sort of safe as we can make it for now. So I will take the foot pedal, put it on the floor. We're going to plug this in. Like so. Okay, I'm in comfortable foot pressing range. This is actually a pretty limber cable, but it's been kind of packaged since God knows when from China. So it does have its memory shape. Also going to use this multimeter here. That's DC volts. Do we have an AC volts? Volts AC, there we go. 200 volts. And we're going to check between line and neutral. That's the brilliant thing. They have a little test port here, but you can just put the leads in there. And like, let's say this is the first time I use this multimeter for AC line voltage. Oops, looks like I didn't put this one far enough. Good thing I know now. There we go. Now let's say it's the first time I put this in AC. Well, it's probably a good idea to test it hands-free, because this is a Chinese meter of unknown origins. Alright, plug in my IEC. My switch is off. I'll turn it on. This should read nothing. Okay, 3.2 volts. I don't know where that's leaking from, but there you go, 3.2 volts AC. Click down on the switch. There we go, 121-ish volts. Let go of the switch. Yep, back down to basically nothing. So there you have it. It works. So I guess now we should do something a little silly and plug in some electronics. So what I have here that you're going to have a hard time seeing because it's so small is a 1 meg ohm resistor and an LED. So the 1 meg ohm is brown, black, black, that's 100, and then green, yellow actually, which is 4, which means 4 zeros. So 100 plus 4 zeros, 1 meg ohm resistor. And here is just a standard white LED. And what I'm going to do, and it could be very silly, but we're going to learn together, is I'm going to solder them together, stuff them in here across the mains, and see if 1 meg ohm would be enough to drop enough voltage to, or enough current I should say, I guess, to make this LED survive and not go in a puff of smoke. I think it should be fine. I'm pretty sure Big Clive does stuff like this all the time. I'm not Big Clive, but I can always pretend. Gonna bring the helping hands in this time instead of trying to do this freehand. So here we go, and here we go. See if I can get them close enough together. If you're not comfortable with doing these sorts of things, working with relatively high voltages, don't do it. But I'm telling you now that I'm going to. Okay. So let's just stuff one end here. I just double checked that it was off, but I guess it doesn't really matter because I have the foot switch for a reason. Okay, and maybe I could flip this around. There we go. So this could blow up in my face, but I highly doubt it. Alright, so on and contact. Ooh, it's lit. I don't know if you can see it. Might be flickery. Okay, gonna turn it off. Point this towards the camera. I think I'm pretty safe in holding this block. It is of Chinese origin. I'm gonna turn this back on. There we go. So we have an LED lit across the mains voltage. I did this as safe as I think is conveniently possible. And with this, that means I need to go off and test some AC voltage stuff. Thanks again very much for watching.